Beneath eastern California, a powerful force is stirring, hidden from view but impossible to ignore for those who study the Earth's restless heart. Scientists at the USGS have released new data confirming a massive volume of magma is on the move, deep beneath the Long Valley Caldera, one of the largest calderas in North America. This is happening right now, under one of America's most geologically active and closely monitored regions, where the land itself tells a story of ancient eruptions and ongoing change. Sophisticated sensors have detected accelerated ground deformation, swelling and sinking of the Earth beyond previously recorded levels, signaling that something significant is unfolding below. This isn't a minor tremor or a routine shift. It's clear evidence of a significant magmatic intrusion, a fresh injection of molten material into the supervolcano's complex system, increasing the pressure and potential for future activity. The scale of this new flow marks a fundamental change in the caldera's behavior, from quiet slumber to a state of active restlessness, a transition that scientists have long anticipated but rarely witnessed in real time. Imagine, if you will, a river of rock, thousands of degrees hot, forcing its way through the Earth's crust, reshaping the landscape from below and altering the very foundation on which we live. The magma is migrating, accumulating and changing the stress on the rock above, generating tremors, releasing gases and lifting the ground, each movement a signal, each tremor a message from the depths. For communities from Mammoth Lakes to Bishop, this geological drama is unfolding directly beneath their lives, a silent force shaping the future of the region and the safety of its people. The urgency is real. While there's no immediate sign of eruption, the scale of magma movement is a geological headline, demanding attention and respect from scientists and citizens alike. It's a stark reminder that our planet is dynamic and ever-changing, its surface shaped by forces that operate on timescales far beyond our daily experience. The forces that shaped our continents, that built mountains and carved valleys, are still at work beneath our feet, reminding us of Earth's ongoing evolution. These events challenge our sense of stability, and compel us to listen to the scientists, to learn from the data, and to prepare for whatever the future may hold. We must understand the profound implications of this new chapter in California's sleeping giant, for the story of the ground beneath our feet is still being written, and we are all a part of it. To truly grasp the significance of this remarkable place, we first need to understand what a caldera actually is, and why it matters. Unlike the classic image of a towering volcano, a caldera is a vast, sunken depression. It forms when a massive volcanic eruption empties the underlying magma chamber, causing the ground above to collapse dramatically inward, leaving behind a huge crater-like basin. The Long Valley Caldera, which was born in a cataclysmic eruption 767,000 years ago, stands as one of the world's largest and most impressive calderas. That ancient eruption was so powerful, it ejected over 1,400 times more ash than the 1980 Mount St. Helens eruption, spreading volcanic ash across much of the western United States and altering the landscape for generations. Today, the caldera is a breathtaking landscape, dotted with steaming hot springs, bubbling fumaroles, and the popular Mammoth Mountain Ski Resort, built atop younger volcanoes that have risen within the caldera itself. Every year, millions of visitors come to hike, ski, and explore, often unaware of the immense geological forces quietly at work beneath their feet. The caldera remains very much alive, with a magma chamber below that still causes the ground to rise and fall, triggers earthquakes, and fuels ongoing volcanic activity. In the late 1970s and early 1980s, a period of dramatic unrest, including swarms of earthquakes and rapid ground uplift, prompted the USGS to launch a volcano watch and install advanced monitoring systems. Today, scientists believe the current activity may signal a new, more significant phase in the caldera's restless history, making close observation more important than ever. Its close proximity to towns like Mammoth Lakes and major highways means that any changes in the caldera's behavior could have immediate impacts on local communities and infrastructure. Even a relatively small eruption here could send ash clouds across vast distances, disrupt air travel, and affect millions of people throughout the region. That's why understanding Long Valley's ongoing behavior is absolutely essential. not just for scientists, but for the safety and stability of the entire region. Recent data from Calvo reveals a specific area in the caldera has risen nearly 10 inches in 6 months, unprecedented in modern monitoring. This swelling is caused by a new magma intrusion, about 3 to 5 miles deep. The volume is at least 0.5 cubic miles and growing. Seismic imaging shows the intrusion is being fed from deeper below, fracturing rock and generating thousands of small earthquakes. These swarms are concentrated beneath the uplift, providing clear evidence of the intrusion. Volcanic gas emissions, carbon dioxide and sulfur dioxide, have also increased, especially around the resurgent dome. These changes are classic signs of fresh, gas-rich magma rising. The combination of rapid uplift, seismic swarms, and increased gas emissions tells a powerful story. Long Valley is in a dynamic, evolving magmatic event. Detecting magma flow miles underground is a scientific feat, made possible by a sophisticated USGS monitoring network. High-precision GPS stations track ground movement with millimeter accuracy, while INSAR satellite radar maps reveal patterns of uplift and subsidence. Together, they provide a comprehensive three-dimensional view of the caldera's changing shape. A dense network of seismometers records constant tremors, allowing scientists to track magma's path through the crust. Current earthquake swarms are tightly clustered, pinpointing the new intrusion. Geochemical monitoring, sampling hot springs and gases, detects changes in volcanic emissions, signaling magma's approach. Increases in gases like sulfur dioxide are direct signs of rising magma. This integrated approach, geodetic, seismic, and geochemical, gives scientists confidence in interpreting events. It's the backbone of timely, accurate updates. To truly grasp what's unfolding beneath our feet, we turn to the detailed USGS maps and charts. These resources are essential for scientists, providing a foundation for understanding the complex geological changes happening in real time. The latest INSAR deformation map reveals a striking bullseye of uplift, 10 inches in just 6 months, centered precisely on the southern caldera. This rapid change is both unusual and significant, drawing immediate attention from geologists. These visualizations make the invisible force of rising magma visible, pinpointing exactly where the ground is being pushed upward. It's a rare opportunity to see the hidden dynamics of the Earth in action. A 3D map of recent earthquakes uncovers a dense cloud of seismic activity between 3 and 5 miles deep, outlining the path of the new magma intrusion and helping scientists track its movement. Animated arrows show the direction of pressure, mapping out the stress on the surrounding rock layers. This helps researchers predict where fractures or further uplift might occur. When we compare this data to historical patterns, the current event stands out dramatically. Uplift rates have shot up in 2025, far exceeding previous years and raising new questions about what's next. The sharp incline on displacement graphs underscores the anomaly, signaling that something extraordinary is happening beneath the caldera. Globally, only a handful of calderas, such as Yellowstone and Campi Flegrei, show similar levels of activity, but Long Valley's current rate is both faster and more localized than most, making it a unique case. These visualizations place Long Valley among the world's most actively deforming calderas, highlighting its significance in the global context of volcanic activity. The global context underscores the seriousness of the situation, reminding us that what happens here could have implications far beyond California. Comparing Long Valley to other calderas is crucial. Yellowstone, with its massive magma reservoir, has ongoing deformation, but Long Valley's current uplift rate surpasses recent Yellowstone episodes. Campi Flegrei in Italy experienced dramatic uplift and evacuations in the 1980s. Long Valley's rate now echoes those early warning signs. New Zealand's Taupo caldera also shows unrest, and international collaboration helps refine monitoring and response. These comparisons show Long Valley is now among the world's most closely watched volcanic systems. The processes, magma intrusion, ground deformation, seismicity, are universal. Studying other calderas helps scientists predict possible outcomes here, from continued unrest to a small eruption. This global perspective is essential for a sober, science-based assessment. With a massive magma flow, the key question is risk. The USGS alert level is advisory. An eruption is not imminent or certain. Many intrusions stall and cool without erupting, but escalation is possible. The most likely eruption would be small and explosive, forming a new crater or cone. or effusive, with lava flows. Hazards include ashfall, lava flows, and pyroclastic flows, threatening communities and infrastructure. Seismic activity could intensify, causing stronger earthquakes. Magma movement may trigger sudden steam-driven explosions, phreatic eruptions, posing risks in tourist areas. Volcanic gases can accumulate dangerously in low-lying areas. Scientists and officials prepare for all scenarios, using refined hazard maps to guide emergency planning. These maps identify evacuation zones, road closures, and safe areas. Understanding these risks is the first step toward effective preparedness. The path forward is clear: enhance monitoring and boost preparedness. The USGS is deploying more seismometers, GPS stations, and gas monitors to track the magma in real time. Communication is critical. Regular updates and town hall meetings keep residents informed and combat misinformation. Emergency agencies are updating response plans, running drills, and preparing evacuation routes. Residents are urged to have emergency plans and stay informed through official channels. This unrest is a real-world drill, testing the region's readiness. While we can't stop a volcano, we can reduce its impact through vigilance, planning, and education. Long Valley Caldera has entered a new, significant phase. A massive magma flow is intruding into the shallow crust, causing unprecedented ground swelling, earthquakes, and gas changes. This isn't a prediction of eruption, but a confirmation of major geological change. The monitoring network provides a clear, data-driven view. There's no cause for panic, but every reason for serious attention and preparation. The current unrest is a powerful reminder of our dynamic planet and a test of our scientific readiness. We have the tools to see the giant stirring and the knowledge to prepare, but nature's timeline is its own. The question remains: are we truly ready for what might come next?